I want to talk about exponential smoothing. Exponential smoothing is a method of forecasting that uses weighted averages as past observations to make predictions about future values. And there are lots of applications of exponential smoothing in finance, business, and economics. For example, in finance, we might use it for stock price forecasting, for volatility estimation, or for interest rate modeling. In business, we might want to forecast sales, or we might want to do some demand forecasting or some inventory management. In economics, we might use this for inflation or exchange rate predictions. So the model is ft plus 1 equals alpha times yt plus 1 minus alpha times ft. ft plus 1 is the forecast for the next period. ft is the previous forecast, and yt is the current observation. Alpha is this smoothing parameter, which is between 0 and 1. So this tells us how much we're going to weight the current observation and the previous forecast. So if it was 0.5, you'd be weighting them equally. If it's less than 0.5, you're going to be weighting the previous forecast more than you're weighting the current observation. If it's greater than 0.5, then you're going to weight the current observation more than the previous forecast. So let's go to Excel and see if we can't do a little bit of forecasting here. So I have some prices for 12 months, and I'm going to pick an alpha of 0.4, which means that 1 minus alpha is 0.6. If we don't happen to have a forecast for period 2, we'll just use the previous month's price. So our first forecast really begins in month 3, and we'll use the formula we have, alpha, and I'm going to hit the F4 key to lock the cells, times the current observation plus 1 minus alpha, and again I'm going to hit the F4 key to lock that cell because I'm going to copy it down, times the forecast. And what do I get? I get 44.8, and I can copy all of this down here. I can either drag and drop, or I can just move over here and I can double click the left mouse key. And let me just reformat that so it looks a little bit nicer. All right, now let's compute the error terms. In this case, let's compute the absolute value of the error terms. So this is going to be equal to the forecasted value minus the actual value. And again, I'll just copy that formula down by double clicking. I can also calculate the error squared. So I'm just going to square these values here and copy that down. So down here I have mean absolute deviation, right, or mean absolute error. So I'm just going to use the average function and copy and highlight that. And I'm going to calculate the mean squared error, which is again just the average of the squared error terms. And we get these values. Now, we provided alpha, or we chose an alpha of 0.4, but is there an optimal alpha given the data? So what we can do is we can use the solver function in Excel to find that, to compute that. So if you hit the Data tab, you'll probably see Solver over here. If you don't see it, then go to File, Options, Add-ins. Down here it says Excel add-ins. Click Go, and just make sure the solver add-in is checked off. So let's see if we can't do this and find what the optimal alpha is for these different objective functions. Okay, mean absolute deviation. So I'm going to click solver, and what do I want? What's my objective function? The mean absolute deviation. Now I can choose to maximize it, minimize it, or I can set it to a value. I want to minimize that. And I want to minimize that by changing alpha. We also want alpha to be between 0 and 1. So down here, it's probably a little bit small to read. It says make unconstrained variables non-negative. So I have that block checked off. So that means that's going to be 0 or greater. I also want it to be less than 1. So I'm going to add the objective function that says that this value, and there's a drop-down menu. The first choice is less than or equal, which is actually what I want. So you have less than or equal, equals, greater than or equals, etc. So I'm going to leave it at that, to 1. And I'm going to say OK. And so I've got that set up. And I'm just going to click Solve. And I'm going to click OK. And here it solves that the alpha with an alpha of 0.55345 minimizes that absolute deviation. We can also do it for the mean squared error. So let me go back to solver. And we're going to get kind of an odd answer here, but let's do it anyhow. So I'm going to take the objective function, which is mean squared error. Okay, we want to minimize it. Okay, we want to change the same variable, so we don't have to change anything here. And I'm going to say solve, and I'm going to say OK. And it turns out in this case, you simply want to use the current observation as your forecasted value. So it's sort of an odd solution. I went back and checked to make sure that was right, but you can see it's a much smaller mean squared error than it was before. All right, so this is the way you can use Excel to solve for the alpha. Okay, and it depends on what objective function you happen to have here. And when we got mean absolute deviation, it would be about 55% in weighting the current observation, so alpha of 0.55, and then the previous forecast about 0.45. So I hope you found this useful, and thanks for watching.